Welcome again. In this lecture, I will discuss about the homogeneous linear partial differential equation of order more than 2 with constant coefficient. So first of all, let us define the homogeneous linear differential equation. Homogeneous linear partial differential equation of order more than 2 of order 2 or 2 and higher with constant coefficient. Homogeneous linear partial differential equation of order 2 and higher with constant coefficient. Let us suppose that z is a function of two variables, and suppose that capital D is the partial differentiation of z, partial differentiation with respect to x, and capital D dash is the partial differentiation with respect to y. Then denote, here we will denote del z upon del x by p, del z upon del y by q, or r will be del 2z upon del x2, s will be del 2z upon del x del y, and t will be del 2z upon del y2. And here we can also write r as this is your del 2 upon del x2, that means 2 time differentiation with respect to x, so we can write it as del 2z, and this t can be written as del 2 d dash square z, and this s can be written as d, that means partial differentiation with respect to x, then partial differentiation with respect to x, y, then it can be written as d dash of z, and this is your dz, and that is your d dash z. So we will need these notation in our problems. Now consider homogeneous. Consider the partial differential equation a naught del n z upon del xn plus a1 del n minus 1 del n del xn minus 1 into del y z plus a2 del n z upon del xn minus 2 del y square plus dot dot an del n z upon del y n equal to some r of xy. Now here you can see that order of each term is equal to n. That is why we are calling it homogeneous, because it has degree, it has order n. We can also write it as a naught del, if you write del upon del x as capital D, then this will be your a naught d power n plus a1 d power n into dn minus 1 into d dash plus a2 d power n minus 2 into d dash square plus dot dot an d dash power n z is equal to r of xy. So this is known as homogeneous linear differential equation. This is known as homogeneous linear differential equation with constant coefficient. So this is known as homogeneous linear differential equation with constant coefficient. We can also write it as, this is some function of d dash, so we can also write it as f d dash of z equal to rxy. Complete solution of 2 is z equal to cf plus pi. The complete solution of this equation, this partial differential equation, is complementary function plus pi, where our cf stands for complementary function and which is the solution of this equation. That means when your right hand side is 0, then the solution of this differential equation is known as complementary function, and pi is also known as, its full form is particular integral, and this is the particular integral of this differential equation is equal to 1 upon f of d dash, and in the bracket we will have rxy. So the particular integral of equation number 2, that is the differential equation 2, will be your 1 upon f dt dash r of xy, and your complete solution is cf plus pi, where cf is the complementary function, which is the solution of this homogeneous differential equation where your right hand side is 0. Now let us find out the complementary function. Complementary function. Let a naught d power n plus a1 d power n minus 1 d dash plus a2 d power n minus 2 d dash square plus an d dash power n of z equal to 0. That means our right hand side is 0. Now if your right hand side is 0, let us assume its auxiliary equation as let z equal to some function of y plus mx is the auxiliary solution of, suppose that this is your auxiliary solution of this equation, say a. So let us suppose that z equal to f of y plus mx is the auxiliary solution of this equation number a. Then its nth derivative, here you can see that we have to find out the nth derivative. Now the nth derivative of this will be the first derivative of this, that means the differentiation with respect to x will be, now the differentiation of this will be, the differentiation of this z with respect to x will be the differentiation of function, say it is your f dash, and then the differentiation of the bracket with respect to x will be your m. So this is your dz. D square z will be del to z upon del x2. That means the differentiation of this z with respect to x, and we have to perform this differentiation 2 times. So the double derivative of this one will be your f double dash, and after one time differentiation we have got l. So after 2 time differentiation we will get m square, and so on. Similarly, del n z will be your m power n fn y plus mx, and let us compute the partial differentiation. Now the partial differentiation with respect to y will be, now the partial differentiation of this function with respect to y will be f dash y plus mx, and as the coefficient of y is 1, so we will have 1 at this place, and the double derivative will be f double dash y plus mx, and the double derivative, suppose that the first time with respect to x and then with respect to z. Now this dt dash z, it means d dash of d dash of z. This will be your, now d dash of z was your f dash y plus mx. Now we have to differentiate with respect to x. So after one time differentiation with respect to x, we will get m. So here we will have m, then f double dash y plus mx, and so on. So let us put these values in this equation number 1. Let us put the first derivative of z with respect to x as m f dash y plus mx, and the double derivative, and here we have the nth derivative. Let us put these values in equation number a. So if we put these values in equation number a, we will get, thus by a, here you can see that we have the nth derivative with respect to x. So this will be your a naught d power n. D power n was m power n f n y plus mx. Let us take this f n y plus mx common, because we will also get f n y plus mx from this term. Here you can see that we will have a1, n minus 1th derivative will be your m power n minus 1, and the first derivative with respect to this y will be your f dash. So this will be your power n. So here you will get the n minus 2th derivative means m power n minus 2, and the differentiation with respect to d dash means just f double dash. So the combined power will be n, and there is no coefficient when we differentiate with respect to y. So we will get an of fn y plus mx equal to 0. So after putting these values in equation number A, we will get this equation. And this function is arbitrary, that means we can have another function which is not equal to 0. So because this function is arbitrary, that means it is not necessary to be 0, therefore this bracket has to be 0. So if this bracket is 0, then this equation is known as, auxiliary equation. This is known as auxiliary equation. Please note that here you can see that if you compare this equation with equation number A, then you can see that here our D, if we compare this equation with equation number A, then you can see that here our D is replaced by M and D dash is replaced by 1. If you check this equation number B and A, then you can observe that our D is replaced by M and D dash is replaced by 1. Only in that case where the differential equation is homogeneous. So to find out the auxiliary equation, we will replace our D by M and D dash by 1. So this is your homogeneous, this is your auxiliary equation. Now as we can see that here the degree of the homogeneous equation is, as the degree of the auxiliary equation is n, so this equation will have n roots. Now case first, if all the roots of equation B are distinct, are different, say m equal to m1, m2, m3 and mn. Suppose that these are the n distinct root, then our complementary function will be f1 y plus m1x, because this was your solution. Our auxiliary solution was f of y plus mx. Now as our first root is m1, so the first solution will be f1 y plus mx. Then we will have f2 y plus m2x. Then for the third root we will have f3 y plus m3x. And then for the nth root we will have fn y plus mnx. So if all the roots are distinct, then this will be your complementary function. So you have to remember this formula. If m1, m2, m3 mn are the distinct roots, then this will be your complementary function. Okay. Now if the roots are equal, if roots of B are equal, say m1 equal to m2 equal to m, and other roots are distinct. Suppose that these two roots are equal and other roots are distinct, then our CF will be, now as two roots are equal, so our complementary function will be f1 y plus mx. Because these m1 and m2 are equal to each other, so second root will be your f2 y plus mx, and here we will have a coefficient x. As the first, for m equal to m1 equal to m, our solution will be f1 of y plus mx. As m1 and m2 are equal to each other, so our next solution will be x times f2 y plus mx. If we will not write this x, then we will have n minus 1 solution, and that means the degree of, as the degree of the differential equation was n, so we must have n roots. That is why we have taken x here, so that these two terms not combine. So the third term will be f3y plus m3x, because all other roots are distinct. So this will be your This is your complementary function when the root m1 and m2 are equal to each other. Suppose m1, m2, m3 are equal to each other, then we will have f1 if m1, m2 and m3 all are equal to m. Then suppose that we have only 3 roots, then our CF will be f1y plus mx plus x times f2y plus mx plus x square times f3y plus mx. So this will be your complementary function in this case. Now let us find out the particular integral. Let us find out particular integral. So first of all, this was your particular integral r of xy. Now first formula. Suppose that r of xy is some function of ax plus by. I am just writing the formula, so you will have to remember this formula. Now suppose that here we have some function of ax plus by. For example, e to power ax plus by, sin x plus y, cos x plus y, log x plus y, tan inverse x plus y, or simply x plus y, or x plus y whole square root of x plus y. If we have these type of functions, then the particular integral will be, here we will replace our d by a, d dash by b, and we will integrate this term, we will integrate this bracket up to the degree of this d and d dash. Suppose that this homogeneous differential equation has degree 2, then we will integrate this bracket 2 times with respect to, now suppose that here the degree is n, suppose that this f dt dash has degree n. So here we have written n times, and we will integrate this function with respect to u, where u is our ax plus by. That means this is the very simple formula. For that we will replace d by a, d dash by b, and will integrate this bracket up to the degree of d and d dash, and we will assume that this bracket is a single function, say u. Otherwise there will be problem. You have to guess whether you are differentiating with the d or d dash. But if you assume this one as u, then we will integrate this one with respect to u, where the integration is done up to the order of f d d dash. Here we have done the integration up to the order of this function. Please again note that this f of ab has to be non-zero. This function ab has to be non-zero. Now if it is 0, if fab is 0, then suppose that this function is 0, then we will differentiate this function with respect to d. Then we will differentiate this function with respect to d. Now if we are differentiating with respect to d, then we will write in the numerator x, and finally after differentiation we will replace d by a and d dash by b, and we will have the function ax plus by. This is when your fab is equal to 0. Now if fab equal to 0, then we will write in the numerator x, and we will differentiate the denominator with respect to d, and finally we will put d equal to a and d dash equal to b. Now if it is again 0, then we will further integrate, we will further differentiate this term with respect to d. That means there will be a double derivative, and we will have x square, and so on. Now it is not necessary to differentiate with respect to d. We can also differentiate with respect to d dash, and this can be also equal to y and the differentiation with respect to d dash. So we can also write it as like this of f of ax plus by if f of ab equal to 0. Here there is no need to integrate this bracket. We will just have to replace our d by a and d dash by b after differentiation with respect to d or d dash. So this is your answer. This is your particular integral in this case. For example, note, suppose that we have this function f of d dash, and in the bracket suppose that we have e power ax plus by. Then our d will be, suppose that here degrees, example, suppose that here we have d square minus d dash square, and here we have e power x plus y. So you can see that in the bracket we have some function of e power x plus y. So we will replace our d by a and d dash by b. So here your a is 1. So we will replace our d by a, that means 1, d dash by 1. So you can see that this is your 1 minus 1, which is 0. Now as it is 0, so we will write in the numerator x and we'll differentiate this denominator with respect to d. Now the differentiation of this term with respect to d will be your 2d, and in the bracket we will get e power x plus y. Now 1 upon d stands for the integration. So the integration of e power x plus y with respect to d means x, because d was your del upon del x. So the integration of e power x plus y with respect to x is your e power x plus y. The integration of e power x plus y with respect to d means with respect to x. So the integration of e power x plus y with respect to x is your e power x plus y. So this will be your answer in this case. That means this is your pi. And now suppose that if this is your d square plus d dash square of, say, sine x plus y. Here you can see that the degree of this term is 2. Here you can see that the degree of this homogeneous differential equation, homogeneous term is 2. And if we put our d, if we replace our d by a, that means 1, then we will have 1. If we replace our d dash by b, here you can see that our b is 1. So this will be a 1 plus 1. Now as the degree of this term is 2, please remember the formula 1. As the degree of this term is 2, so we will integrate this term 2 times with respect to some variable u, where u will be x plus y. There is a difference between these two questions. In the first question, our denominator was 0 at a comma b. Here you can see that our a is 1 and b is 1. So this was 0. So we have used different formula. In the numerator we have written x and we have tried to differentiate with respect to d. And here you can see that as the denominator is not equal to 0 at a comma b, so this was your 2. Now as the degree of this term was 2, so we are trying to integrate this term with respect to u, with respect to your term u for 2 times. So now the integration of sine u, first time integration of sine u will be minus cos u. So this will be your minus cos u, and then again integration with respect to u, and integration of cos u will be minus cos, integration of cos u will be your sine u. So this will be your sine u, and u was x plus y. So this will be your pi in this case. So this is your pi. Now let us move towards the formula number 2. Second, pi. Suppose that we have this type of function, and the bracket, suppose we have sine ax plus by or cos ax plus by. We can solve this, we can find out this pi with the help of this formula number 1. Now if you not wish to use this one, then we will use this formula, which is your replace our d square by minus a square, dd dash by minus ab, d dash square by minus b square, sin x plus by or cos x plus by, where our d square is equal to minus a square, dd dash equal to minus ab, and d raised to square is equal to minus b square. Again, this is true when your denominator is not equal to 0. Now, if the denominator is 0, then we will write x in the numerator and we will differentiate this one with respect to d. Generally, we will not use this formula. We will try to use the formula number 1 because formula number 1 is very easy. Third, suppose that our rxy is e power say x power n into y power n. Suppose that this is the function rxy. Now this can be written as, if our n is greater than or equal to n, then we will take d common, and then this will become your, if we take d common, then here we will get some function of d dash upon d. Now if the function is of the type d dash upon d, then we will take this term in the numerator, so then this will be your, then pi will be 1 upon d, some function of, or you can say that we will get some function of 1 plus or minus some function of d upon d dash upon d, and as we are taking this term in the numerator, so we will get this term. As we are taking d common, so in the bracket we will have some function of d dash upon d. Now if this is the function of d dash upon d, then we will take this term in the numerator. Hence, after opening this bracket with the help of the binomial expression, we can get this particular integer. So after opening this bracket with the help of the binomial expansion, we will get the answer. Now if n is greater than n, then now if the power of y is greater than power of x, then we will take d dash common. Now if we will take d dash common, then here we will get some function of d dash, d upon d dash, and again using the binomial expansion, we will get the Pn. So when in the bracket we have the terms like this, some product of x into y, then we will use this type of particular integral. Then the fourth formula, which is your general formula, general rule. Suppose that here we have some linear factor like 1 upon d minus md dash, and in the bracket say there is some function of x comma y, which is your rxy. Now if we have linear factor of the type 1 upon d minus md dash, suppose that here we have the linear factor of the type d minus md dash, then our pi will be integration, we will replace our y by c minus mx, where we have replaced our y by c minus mx, so we can say that our c is y plus mx. So if your c is your y plus mx, then you can say that this is your again r of xy. So this is the general rule for the particular integral. That means when your linear factor is of the type d minus md dash, we can solve any question with the help of this one, provided that there is a linear factor of the type d minus md dash. Okay, let us solve few questions. Question number 1. Solve the differential equation part PDE. Solve the PDE, that means partial differential equation, del cube upon del z, del x cube minus 2 times del cube upon del z, del x square del y equal to e to the power x plus 2y plus 4 times sin x plus 2y. Let us solve this question. Solution. First we will find our complementary function. For the complementary function, our right hand side should be 0. So this can be written as, so this has to be your 0. Now as our notation For del by del x was d, so we can write it as d cube, and this will be your 2 times del 2 upon del x, so that means this will be your d square, and we will have d del upon del y, which is your d dash, and we can take z common, so this will be equal to 0. So this is your partial differential equation. Now auxiliary equation. Auxiliary equation is, for the auxiliary equation, please remember the equation number b. For the auxiliary equation, we have replaced our d by m and d dash by 1. So for the auxiliary equation, we will replace our d by m and d dash by 1. So this will be your m cube minus 2 m square equal to 0. For the auxiliary equation, we will replace our d by m, d dash by 1, and z was your function, which is your arbitrary function. That means it is not necessarily 0. So this will be equal to 0. Now if this is 0, then from here we will get m square, m minus 2 equal to 0. So our root will be 0, 0 and 2. Therefore our complementary function is equal to, we have 3 distinct roots, so solution will be f1 y plus mx, m is 0. Then we will have f2 y plus mx, m is 0. Then we will have f3 y plus mx, m is 2. So this will be your complementary function. Now pi, now particular integral will be 1 upon d cube minus 2 d dash square into d dash, d cube minus 2 d square into d dash. In the bracket we have each power x plus 2y, I think there was x plus 2y, and plus 4 sin x plus 4x plus y. I don't know what was the exact term in the bracket. Let us suppose that this is your right hand side. If this is the right hand side, then we will partition in 2 parts. This one, and then we will have here. Okay. Now this will be your, here you can see that we will replace our d by a and d dash by b. So this is equal to, if we replace our d by a, that means a is 1. So this will be 1. Now here d is 1. So this will be 1, and d dash is 2. So this will be 2. We are placing our d by 1 and d dash by b. b is 2. So this will be 1 upon 1 minus 4. In the bracket we will have e to power x plus 2y. Then again here, okay. Now this is non-zero and the degree of this term is 3. So we will integrate this bracket 3 times. As we know that the integration of e to power x plus 2y is e to power x plus 2y, we can add the degree of, as the degree of this term is 3, so we have replaced our d by a, d dash by d, d dash by b, and we will integrate this bracket 3 times with respect to u. And as we know that the integration of e to power u is e to power u, so we can also say that we will simply replace our d by a and d dash by b, and there is no need to integrate this bracket because the integration of e to power x is e to power x, where our u was x plus 2y. And for the second part, again we will replace our d by a, that means x, and d dash by 2. So we will get 1 minus 2 into 1 into 2, and in the bracket we will have to integrate this 4 sin x plus 2y for 3 times because the degree was 3. So let us say this is your v, where our v is x plus 2y. Because u and v are common, so we can say this is equal to u. So where our u was x plus 2y. Hence our answer is, this will be 1 minus 1 by 3. Integration of e to power u is e to power u. So we can say that this is your e to power x plus 2y. And here this will be 1 minus 3. Now the integration of sin u, one time integration of sin u will be minus cos u. Then Further, second time will be your minus sin u, and then third time will be your plus cos u. So this will be your 4 cos u, and u was your x plus 2y. Because 3 time integration of sin u will be 1 time of integration of sin u will be minus cos u. Then second time will be your minus sin u, and the third time will be your cos u. So this will be your integration of 3 time integration of sin u. So this is your answer. Therefore, our final answer will be z equal to cf plus pi. So our cf was f1y plus f2y plus f3y plus, I think that was 2x, f3y plus 2x, because we have 3 roots 0, 0, 2, and your pi is minus 1 by 3 e to power x plus 2y minus 4 by 3 cos x plus 2y. So this is your complete answer, which is a combination of complementary function and particular integral. Let us solve another question. Solve four d square minus 4d d dash plus d dash square z equal to 16 log base e x plus 2y. Let us solve this question. Solution. For complementary function, our right hand side should be 0, so this will be 4d square minus 4d d dash plus d dash square of z equal to 0. Now our auxiliary equation will be, auxiliary equation is, let us replace our d by m, so this will be 4m square, 4m, and d dash by 1, so this will be equal to 0. And here you can find out its root, so this is your 2m minus 1 whole square equal to 0. A square plus b square minus 2ab. So we can see that here m is equal to half comma half. As degree is 2, so we must have 2 roots. So we have 2 root, one is half and another is again half. Therefore your CF is f1 y plus mx plus h2, as these roots are equal to each other, so we will have x, f2 y plus half x. So this is your complementary function. We can also write it as, this term can also be written as, because as we are writing functions, so these functions can also be written as some function of y plus 2y plus x plus some another function of 2y plus x. As we are talking about the functions, so there is no need to write this 2 here. So we will say that this is a function of 2y plus x, and we can say that this is your x times some function of 2y plus x. So this will be your CF. Now pi will be 1.4d square minus 4dd dash plus d dash square, and then in the bracket we have 16 log to the base e x plus 2y. Now this was your, this term can be written as a square plus b square minus 2ab. So this is your 2d minus d dash whole square. Now here we can replace our d by 1 and d dash by 2. Now if we replace our d by 1, d by a, where our a is 1, and d dash by 2, then you can see that this is your 0. Now as this term is 0, so we will write in the numerator x and we will differentiate this term with respect to d. So the differentiation of this term with respect to d will be your 2 times 2d minus d dash, and then the differentiation of the bracket with respect to d will be your 2. In the bracket we will have 16 log e x plus 2y. Now again you can say that as d is 1, as our a is 1, and d dash will be replaced by b and b is 2, So this is again 0. Again this is 0. So we will write 1x in the numerator. So this will be your x square. And now let us replace our d by a. A is 1 and d dash by 2. So this was your 0. So we have written 1x in the numerator and we will differentiate this term with respect to d. So the differentiation of this term with respect to d will be your 2. And hence we will get 2 into 2 into 2. That means 8 into 16 log base d x plus 2y. So our answer will be 2 times x square log base e x plus 2y. And this term is 0 when we replace our d by a and d dash by b. So as this is 0, so we will write 1x in the numerator and we will try to replace our d by a, that is 1, and d dash by 2. As this was 0, so we will write 1x in the numerator and we will try to differentiate this term, this denominator, with respect to d. So the differentiation of this term will be 2d minus d dash, and then differentiation with respect to d will be of 2. Again you can see that if we replace our d by a, 1, and d dash by b, which is your 2, then this will be of 0. So we will write 1x in the numerator and we will differentiate this term with respect to d, which is your 2. So this will be 2 to 4 into 2, that is 8. So this is your pi. Hence our complete answer will be z equal to cf plus pi, and this is equal to f1 2y plus x plus x f2 2y plus x plus 2x square log base e x plus 2y. So this is your answer.